This learning path is intended to help learners to start their preparation to take the developing solutions for Microsoft Azure AZ204 certification exam. Microsoft Azure developers are responsible for taking part in each phase of the cloud development process. They define solution requirements and design, develop, and maintain those same solutions. Azure developers are also responsible for performance tuning, monitoring for solutions they create, and the content in this path can help you kickstart your exam preparations. So please write down your comments, questions, and suggestions in the comment box. This channel really needs your support. So in order to make these videos visible, please like, share, and subscribe if you haven't done so. To make this content free and available, I put around 100 hours of preparation. So I would really appreciate your thumbs up, and I will not talk about it again in this video. About me, I'm your host and host on this YouTube channel as well. In this video, we are going to talk about Azure App Services, which is part of first part of the first part, creating Azure App Services web apps. Let's continue to the course, and I hope you will enjoy it. Thank you. Good luck. Azure App Service web apps. So this is itself. So as I said, out of 5 parts, this is the first part of the first part. So I will call this as module if in the future of this video, and then this itself is divided into 4 parts: explore and creating Azure App Service, configure web app settings, scale apps in Azure App Service, explore Azure App Service in deployment slots. So let's continue. We talk about create Azure App Service web apps. We will be going through introduction, understanding app service plans, isolation with app service environments, creating web app in the portal, creating web app in Azure CLI PowerShell, and creating web app using ARM templates. So how do you manage and scale web applications running on the Azure App Service? That is the focus of this course. Hey there, this is Nitesh Sharma, your host, and I'm super excited to have you with me in this course. In this module, in this first module, we are going to talk about creating Azure App Service web apps. So let's go ahead and walk through what we are going to cover in this first module. So to kick things off, we are going to basically get an understanding of app service plans. App service plans are essentially the compute platform that run the web application. So we need to have a solid understanding of how those work. In addition to app service plans, there is also a concept called app service environments. This is where we could run isolated web applications. So we will go ahead and take a look at that, and then I will walk you through creating web apps in the portal. I will walk you through creating web apps with Azure CLI, as I already said, with PowerShell, with command line, and with ARM templates. By doing deployment using ARM templates, that becomes infrastructure as code implementation as well. And then in the remaining modules in this course, I'm going to show you how to manage your app service environments, how to manage your web applications, and then we will also take a look at how you can scale web applications for the production environment. Every module is going to include some hyperlinks where you can just go to Microsoft Learn and know more about it. So thanks for staying with me till now, and let's continue the course. Creating web apps in Azure App Service is actually really easy to do for most of the part, but it does require a good understanding of app service plans. But let's first make sure that we are all on the same page, and we'll just take a look at what Azure App Service actually is. So Azure App Service is the HTTP based service for hosting web apps, and it's just basically a very advanced version of web hosting. So that's what it is all about. Microsoft makes it easy for us to run applications that run on Windows platform or on Linux. There is all kind of different frameworks that we can use to run our applications. So for example, we could use ASP.NET or ASP.NET Core. We could also do Node.js, Python, PHP, and bunch of more other frameworks. And with these web apps, we can deploy code directly to app service, or we can use Docker containers. So we have got a lot of flexibility when it comes to running certain application types. A variety of different frameworks are supported, and since app service is managed service, meaning Microsoft does all the heavy lifting. They are going to make sure that environment is secured. There is basically integrated load balancing, and then just with any cloud service, like we always see, we have got the ability to do automation. So we got automation in terms of deploying code to our app service, and we also have got the ability to just automate the deployment of the infrastructure itself. Not only that, we can also auto scale at the compute layer. So behind the scene, the virtual machines are what really power an app service plan, and we can actually say, hey, let's scale out to 2 or 4 instances to support some kind of dynamic load, where we can scale on schedule. A lot of capabilities are there. And when it comes to working with app service, one of the biggest consideration is that costs are determined by the app service plan. So depending on the type of compute environment, the app service plan environment you select, that dictates the cost. So let's continue. There are 2 different types of app service plans, and this is very critical concept here. So 2 types of app service plans that you want to think about. So there is non-isolated app service plan, and there is isolated app service plan. Let's continue to a couple of major points that I want to focus on here. Let's say user can come from the internet, hit the app service, web app, and ultimately our web apps run on top of a service plan. And now these web apps can integrate with other resources. So you can see storage account or other resources, SQL, Azure SQL, database infrastructure, or let's say other apps. The big takeaway that the app service plan can be 1 or more virtual machines. Behind the scene, Microsoft manages the compute layer. They make sure that the virtual machines are patched and they are highly available, and that they are functional, all that kind of stuff. They are also doing a bunch of security things under the hood. Now we also have the ability to implement security controls, as well as in terms of who can actually authenticate and open up our applications from the internet. But ultimately we can deploy multiple web apps on top of an app service plan, and that app service plan is scalable. So the big difference between non-isolated app service plan and isolated app service plan um, that are not inside a virtual network. So this app service plan that we are looking at here is basically your typical app service plan implementation with no isolation at the network layer. Now the majority of app service plan types are non-isolated types. Let's talk about what those are. So non-isolated app service plans types are free and shared. Now there is a big difference to think about these two. The pricing tiers are that they are not intended for production web applications. So free tier is kind of self-explanatory. You don't have to pay for that. And currently, yes, when I'm recording this video, the resources that they give are so pretty low. And the shared plan is also another non-production grade type of app service plan. Now again, low amount of resources, it's very inexpensive. And the other thing that you want to keep in mind, that these that the free and shared actually run on shared infrastructure. So that means that other apps running on the same VMs. And so again, that's another reason why we don't want to run production web apps on free and shared tiers. From there we have the basic service plan. So the basic service plan is designed for apps that have lower traffic requirements. We don't need advanced autoscaling and traffic management features. And again, this is just for maybe some more robust development and testing type of infrastructure, but it basically doesn't have the advanced control that you would need for production grade applications. And so that is why we have the standard tier. The standard tier service plan is designed for running production workloads, and the pricing is based on the number of instances you run. So we will talk about this and in more depth later. But you basically have an app service plan powered by one virtual machine to start with, and we could add more later. We can also add more automatically through autoscaling, which we will cover in the next chapters. There is the premium V2 service plan type. This is designed to provide enhanced performance for your production grade applications. And then finally, there is premium V3 service plan tab. This is just upgraded premium plan for offering that came out recently, and this is now available, which offers faster processors and few other bells and whistles. Now you might be looking at some huge list here and getting worried about memorizing all these little details, but really you just want to make sure that you understand the difference between free, shared, basic, standard, and the premium pricing tiers. So the big takeaway for the clip is that if you want to run web applications in production, you should be using standard or one of the premium tiers, or app service isolated, which we talk about in the next one. um, that we have discussed running web apps in non-isolated environment. Let's talk about uh, isolation with app service environments, also known as ASE. So we had ASE 2 v2, and now we also have ASE v2, sorry 3. So with ASE, this is fully isolated and dedicated environment for running your web apps. So it is still app service, it is still a managed service, but just the big difference here is that you got the entire compute environment for yourself. And but and you also get the isolation of being able to put it in your own VNet. The other nice thing about ASE is that it's designed for high scale, it's designed for high memory utilization. So if you are looking to do more ambitious work on app service, maybe you have got really demanding web application and other pricing tiers that aren't working for you, ASE might be an option for you that you might want to explore. Now, the isolation and secure environment network access is one of the things that most interesting to enterprises. One of the sticking point with doing managed service is lack of isolation at the network layer. So Microsoft changed that with app service. Teams can now put the app service environment inside their own VNet and control all inbound and outbound traffic. So with controlling all the outbound and inbound traffic, ASE can take advantage of existing VPN connections back to on-prem, and you might have a real fast connection back to on-prem environment. And this might be really interesting way to allow on-prem applications communicate with apps that you have got running in your own VNet in ASE. So as you see here, I am in my Azure portal, and I am going to create our first app service. So let's go to on my left side of my panel, let's go to app service, and let's click here, and let's There is already one in the free tier. I have already created one, and I will just want to create one more, let's say. So to create one more, it will go to take me to the to this space where it will say, um, it will by default select my one of the subscription if I have multiple, and then it will ask me to give the source group. I will select tech of the day, and then I can select one of the web app name. And to pay attention here, it should be unique. So if I say the same tech of the day, this name as you see here is already taken, so it is not available. Let me zoom it a little bit. Yeah, I hope it's visible. And you see here, um, how do I want to publish it? It is already asking me if I want to publish it via code, Docker container, or static web app. If I select static web app, then it just asks me to create accelerate your app development with managed global availability with static content hosting and dynamic scale. It is not asking me for anything else. If I go to Docker container, it just asks me for many things like which operating system I want, which region and app service plan, and blah blah blah. But if I just go with the code as well, it will ask me to which runtime stack I want to use, because yeah, if I'm using the code, then it will ask me what do I want to do. So let's say .NET, and which is like you have already .NET LTS, you have .NET Core, you have previous versions of .NET, and then you have Java, Node, PHP, Python, Ruby. I have a lot of options. If I select .NET LTS 6, and then I need to select which operating system I want to use. This is really important, because you might be using few things related to Windows or Linux. Then you should choose wisely according to your app service, and then you select the region where you want to deploy your app. This is still not clear, so I will just put one here. So yeah, it is unique now. It shows green. And then if you see here, it is asking me to select SKU, which is basically in the app service plan. So basically it is asking me to create an app service plan. It says new. If you don't have any, it will just create new. And you can select here with this and create your own tech of the day app service plan, and I just say okay. And then if I want to change the SKU, for now it is using by default standard S1 and 100 ACU and 1.75 GB memory. If I want to change the size, I can just go here, and you see here you have more options like dev test, which has shared uh, shared environment. Then you have for production, you have other options, really a lot of options. And because with the shared, you have pretty low options. See additional options if you want, but you don't have many features like custom domain and all that. But and you see this one is free shared infrastructure. Others are also shared, but they have other more options. um, and the production one has having other options. You have, and these are changing every day, so I don't want to remember them all the time. And then you have isolated, which we just talked, like this is your own private virtual machine, and this is really expensive. You see 691, 1383, or 345. For the production, you still have pretty good options like 123 until 812. You also have other options, but yeah, you have a lot of options. And I will just go with this because yeah, I don't want to pay for it. Let's go. And I changed this the tier, and now I have shared infrastructure and 1 GB memory only. I don't think it is it is enough, but Anyway, we just want to create review and create. So now I'm ready with my app service, and I can just press create and it will be creating. Perfect. Deployment is in progress and we can see that it is going to create. All right, I will give it some time, and oh yeah, it is pretty quick. As you can see, yeah, it's pretty quick. Okay, and I can just go to resource and it is ready. And here you see I have a lot of options which I can just play around. Scale up, scale out, web jobs, custom domain, although this might not be. Yeah, I can have a custom domain. Click here to upgrade service plan to assign custom host name to your app, because it is not allowed in the free domain. Anyway, I don't want to I don't want to do it. You have other options, and you also have getting over. If I go to overview, I have by default this sorry, these details for error and data in and out and other analytics work, which we will talk later. Quick start. In the quick start, I can just deploy it, follow the quick start guide with .NET, PHP or Java, Python, Node.js, and I can just click here and just go with the .NET, and I can just yeah, do a deployment, which I don't want. Yeah, so that was it for creating a web app. Oh, sorry, I forgot deployment slots. So in the upgrade, you have to upgrade to a standard or premium plan to add slots. But what I want to show you is it has production and staging slots, or you can have multiple slots, and you can just switch slots so that your app can swap. So you see here you can add a slot and you can swap a staging environment which is working fine, then you can swap to production and then take the production app for testing. You can do a lot of things with it. Basically it is like you can swap with another ready to use app, and slot is basically like a copy of your existing app. So that's it for creating app using Azure portal. Let's continue with I'm here again in my Azure portal, and we want to create web app using Azure CLI. So here I just can go to uh, PowerShell, and you have an option in your Azure portal to do it with the PowerShell. So but before doing it, it just creates Azure Cloud Shell storage, because it needs to store that somewhere. So it is going to create a storage account. I say create, and let's wait for it. It will take some time. Basically what is happening, it is creating under the hood, under this subscription, it is creating a storage account which will host my PowerShell or Azure CLI command lines, basically to run all this. And it also installs Azure CLI or PowerShell, because if I want to do the same thing if I want to do the same thing in my desktop, or I mean in my personal laptop, I have to install everything. So if I don't want to do that, then it will prepare an environment for me, and then it will have the thing ready for me. So let's see. Okay, requesting cloud cell, and it is ready, kind of preparing for me. And the good part is it will already log in me and give me the ready environment. You can select bash or PowerShell here. Now it is requesting cloud cell and then connecting to the terminal. So basically it is trying preparing the environment for me. And once it is ready, I can just go
and execute my things. But before that, I will just show you what do I have already. So I have, so it is ready, and I just do it like this. I it just created three resource groups. So I created two, tech of the day, and it created cloud cell storage West Europe, for the cloud cell itself. And let's go, and I can just copy paste what I have just from the from my series here. So I can just copy paste it. So I have this CLI command which says create Azure create group, because we need a group, a resource group. I could reuse the existing one, then I don't have to do this one again. And then I'm creating web apps dev rg, which is for resource group, and the location is West US2. App service, so then I need to create an app service plan which is with the name web apps dev plan. In the resource group, this one SKUS1, a host is Linux. And then finally I'm creating my web app, which is a web apps dev rg web app this blah 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 with this runtime node.js. So let's hit and see what happens. So behind the scene, it is executing all my um, commands, and if I go here, it should, in some time, there should be a new resource group. Okay, so I see one thing. Region has a quota of 0 instance for your subscription, because my subscription is free. Um, Unfortunately, um, I'll change the I will change the I will actually reuse the existing resource group, because yeah, that will give me um, now that will give me profit. I don't have to create then the new. um, I will use this one, the existing one, and let's continue. So if I just redo it, and web app create g web app, but before that I need to create a plan, and resource group for that plan will be my resource group then. So I will delete this one, and I can change it to my resource group check of the day. And then, so this will create a plan. We are simply creating Azure App Service plan create with this name and SKUS1 and the host Linux. Once it is created, then I can create the web app. Okay, the plan is created, and now I can just create the web app. But one thing I need to do is I need to change the resource group, because yeah, this didn't work. So I need to put my own existing resource group, because I'm having a free subscription tier. So I'm not allowed to have multiple locations, and unable to retrieve the existing. Sorry, part of the current subscription. Sorry. So I need to change the app service plan as well. Let's see. So finally it created my web app with I needed to change few names. But if I go to my resource group tech of the day, and check the resources here, refresh it, you will see it created app service plan, web app dev app plan, and then it created, uh, look, I'll make it bigger. um okay, so it has quite a lot of number of sources. It created apps a web app dev plan, which I just created, and it created the web app service. I go back here, you see it has all the responses back from it. If I just go to it, and the name was tech of the day 2. So if I just go to this one, copy, and just go to your app is running and waiting for your content, and it is saying Node.js built with Node.js. So my app is ready and deployed with Cloud Cell or Azure CLI. Same way we can do it with PowerShell.
Created a web app using Azure CLI in the cloud. In the Azure portal, you already have that cloud Azure CLI, and you can make use of that to execute your Azure CLI commands or Azure PowerShell commands. And to do that, I just clicked in the portal as you saw in the previous step, and then that led to creation of a storage account, and it prepared an environment for me that could be used to execute CLI commands. And same for PowerShell. If I do it locally, I have to install it, as I said. So I don't want to do that, and that's why I used that option in the portal. Same way, I could do the same thing using PowerShell. And to do that in PowerShell, I'm here creating a PowerShell script, which is basically a PowerShell script having some variables. So git repo, location, web app name, and location. So these are the variables I am having for my PowerShell. So first of all, if you don't know how to use PowerShell, just go through it and notice few differences between Azure CLI and PowerShell. In Azure CLI, everything starts with AZ, and then the source. Here you see everything starts with new or verb. So new, create, remove, blah blah. So everything starts with the verb. Uh, so you see here, I'm creating a new resource group. If I already have one, I don't have to. I will not create it. And here I'm creating app service plan in that location, and the name of the app service plan is name of the web app itself as well, and I'm putting it in the free tier. And then I'm creating a simply web app and its location, and then app service plan is the app service plan I just created, and then resource group name which I just created. So simply I'm creating resource group, app service plan, and then a web app. And in the end, I can just configure GitHub deployment from your GitHub repo and deploy it once. So you can just say you can set these properties, say properties object. You create a properties object with the repo URL, which is get repo here, branch is master, is manual integration is true, and set then Azure resource properties and set the resource properties like this. So you're simply saying you are setting properties for your Azure resource, which is which happen to be a type of web app. Here you see web Microsoft.web.website source control, and then you're setting the source control to that git repo. And you are applying API version here, which is another formality. So basically you can do the same thing with Azure PowerShell, Azure CLI, what we did in the Azure portal. Now next is creating.
So now we want to do the same thing with once we have done with portal, Azure CLI, PowerShell, and we can do the same thing with ARM template as well. And to do that with ARM template, I have this link here, which is from Microsoft Learn, which is quite good explanation of ARM templates, how you want to do it, what is ARM template, how you could do it, and it is explaining also the basic structure of an ARM template here, which has a lot of elements here. So basically to deploy from the ARM template, you can use Azure CLI. So you just say Azure group create, and then you create the resource group, and then you create a deployment. Pay attention here, it is a type of deployment. Let me make it bigger. I guess it is visible now. So you see here, it is so resource group, creating resource group is like, yeah, whatever it is necessary for the deployment. But the basic thing is you need to create a deployment. You just create a deployment in this specific resource group with the parameters you want to apply. So you can send the parameters, and then you are saying template URI, right? And your template, which happen to be your template for the ARM template, so the which happen to be a template for creating websites, uh, is here. So simply you you are using ARM template to create your web app. What is the benefit of having it like this is simply it's like, you can keep the template in your resource control, which means you can create a repository and store that there, and then you can have the version control as well. So you are not doing anything manually by going to the web app itself. Let's say when one resource is not working, you just go there and change few settings, and then oh, this was not working because then I changed few settings here and there, and then I don't know anymore. I don't keep the version of my web service, what changes I did, which was the problem in previous deployments, in previous technologies, without cloud or without version controlling, without, yeah, like when we used to deploy an app using MVC to a on-premise service server, and when things were not working, let's say, and then we used to change something manually, and we don't know anymore what we changed actually. So it's really something really useful. If you want to do it, you should just store your all the changes in source control, and then you can easily track the changes you made. So simply it is an ARM template, and then I can just go here. You see, I can just go here, I can just say deploy to Azure. For Linux or Windows, they have pre-built ARM template, and I can make changes for them as well. You can also do one more thing. You can use your existing, I can use my existing web app, and I can create ARM template for this. So if I go here and if I look for um, export template, and it will simply generate an ARM template, and this will be actual copy of my existing app service. That means I can be rest assured that whenever I will deploy, I will be having proper exact copy of my app service. So it creates everything from the existing settings, and creates an example of ARM template here, and you have a big ARM template here. You see, I can use it, and I can click deploy, and it will start the deployment. You see here, and here I'm just using the existing things, resource group, blah blah blah, site stack of the day name, blah blah blah, and it will creating the ARM template. I will explain you again in detail about the ARM template parameters, template properties. Here I will talk about everything. You see here, report your variables, resources, everything I will talk about. uh, but I hope it's clear how you can use ARM template to create a web app. I will create also a separate video about ARM template and infrastructure as code, which will be a detailed video, because if I continue doing this, it will be a big series. But in terms of exam, it is not that interesting. It is interesting, but I mean, you don't have to go that deep. But I will create another video which will specifically talk about ARM template and bicep as well. So for now, let's continue and see. So let's talk about ARM template structure. If I go to the same page and if I review the template and if I just check the structure here, you see a schema, you see content version, you see metadata, and so in metadata it just talks about how uh, simply metadata, the properties about the template itself. Then you have parameters. Parameters are which are really important for creating the web app, but parameters in the template itself are the parameters which you can then reuse later on while creating the web app itself. So parameters are, let's say here you see web app name, and then it's an object itself which describes the type of the parameter, default value, minimum metadata, description. Again, location, same thing, type, default value, and you see here it is reusing the default value as resource group dot location. So default value is always the resource group location. SKU, which is a property for the app service plan, and I'm taking here F1, which is free tier 1. And then you have the version for that, and here you see it is taking default value .NET Core 3.1, version for the Linux runtime stack, then repo URL, it is taking, yeah, repo URL. Then you have variables, which is app service plan portal name. So then it is creating the variable, the name itself, from the values which you have provided from the parameters itself. App service plan dash parameter web app name. So you see it is creating it from the parameters itself. Then sorry for that. And then you are creating the actual resources. How many resources you are creating here? You see resources, it's an array, it's a list. So you creating one server farms, which is actually creating for your web app. Then you're creating a website. Then you have some conditions with that, and you also have the deployment conditions. So you have depends on, so this will not be executed until blah blah is done. So here once you create the server plan, server farms, and then you create the website. In the website itself you see, you say the type, so the resource type, version, name of the uh, resource, location, and then the properties of that specific resource. So then you have properties http only, site config, blah blah blah. Then one interesting thing is identity. You can assign, you can add system assigned identity or manage user assigned identities here, and then you can, if you have created in advance, you can use that uh, value here, which we will talk in the video I was talking about to create for working with ARM templates, infrastructure as code. I will be creating that video, and I will talk about how you can reuse the resources you have created previously and then assign or reuse those variables here, resources here. And then it has some conditions, contains parameters, repo URL, blah blah blah. So basically, if you could understand from here, you had 5 parameters, and yeah, simply using those parameters, it could, you can create variables, and then you can create resources. So that's it for the structure. Let's continue.
This is the second module of the first part of the first part. Don't be confused. So this is the second module inside Azure App Service, configuring Azure App Service. Module overview, if I talk about, so once your web applications are built and running in Azure App Service, the next step to configure those applications, that what we are going to take a look at this module. So first we are going to talk about securing a web app with SSL, setting up SSL certificate for your web application. This is very simple to do. There is a couple of different options available to us from the Azure platform itself. In addition to securing our web application within SSL certificates, we should also understand how to configure a database connection string, because your web app might be connecting to the database, and then you will need to configure the database connection strings. It is very common for us to have a database here in web application architecture, so we need to understand how to do that. From there, we will take a look at enabling diagnostic logging. This is an important concept. Anytime you are doing continuous monitoring of your web application, then finally, at the very end of the module, we will take a look at the deploying code to Azure App Service web application to your application, to get your application up and running. So that the game plan for this module is, let's move to the next video and we will get started with securing web app with SSL. So to secure web app with SSL, securing web app application in Azure App Service with SSL certificate is fairly straightforward, but there are several options. So let's ahead and break down the details of the important points that we need to understand. So we have seen how to create app service web application, and we know the external users can come from the outside world. They can navigate over to your host name or your website that you provide under azurewebsites.net, or not only under this, but you might have registered your own host name as well. And if they come, and we have seen so far that now user can head over to your URL and they can use both HTTP or HTTPS requests. So by default, there is wildcard certificate available for your applications after you provision them. So any host name under the Azure websites.net will be secured or available for a secure connection over HTTPS. Now in the real world, we usually don't want our end users going to some host name under Azure websites.net, and because of that, that's why we have the ability to map custom domains to our application. So for example, we could take the tech of the day by nk.com domain if we wanted to do, and we could make that resolve over to a web application in app service. And we could also even map the SSL certificate to that web application, and that would ensure the external user uh, going to that domain would get secure connection. And once you have a secure connection to the tech of the day by nk.com domain, if you wanted to, and then tech of the day nk domain as one of the subject names. So now there are several considerations when it comes to securing a domain with SSL and TLS binding in your app service implementation. So let's talk about these considerations. Now, if you remember back to the first module, we were talking about app service plans. So we need to make sure that we are using at least basic, standard, premium or isolated plans types, because it is not available in free tier. So the free and shared tiers are not going to work. We are not going to be able to do SSL certificates with those type of tiers. The next consideration is public versus private certificate. So we could purchase a commercial certificate from a popular certificate authority, something like VeriSign. We can also generate private certificates using our own certificate authority. And so the big consideration here is trust. Is the client devices going to trust the issuing certificate authority? So you are welcome to use private certificate that you generate on your own. You can upload those and bind those to your web application. Just remember that every client device in the world could potentially trust the certificate or the issuing authority. So with that said, public certificates are commonly used, especially with public web application. And here is what where it gets the kind of interesting. So we have the concept of managed versus unmanaged certificates.
So if you see here, I cannot do the custom domain as it say you need to upgrade. So I could just configure the custom domain for this and continue. And then if I talk about TLS and SSL settings, I can say HTTPS only. I can set it true. And then I can also specify um, the minimum TLS version required. So because TLS version is a kind of encryption version which your website needs. As you see, it's a basic plan. I cannot do it. SSL bindings can be used in basic plan and higher scale up to this feature. This feature includes creating managed certificates and adding certificates to your app. So binding TLS SSL lets you specify which certificate to use when responding to request to a specific host name over HTTPS. TLS SSL binding requires a valid private certificate issued for the specific host name. And I can just go and buy a certificate. It will just get me certificate from App Service. Certificates allows to purchase SSL managed SSL certificate within the minutes, and I can just buy a certificate which will be a publicly valid certificate for 1 year, auto renewal, blah blah blah. I can just create it here, or I can generate my own. I can also store private SSL certificates, so private certificate keys and public certificate keys, and I can just upload the public certificate key here. So basically, as you see here, you could do a lot with the SSL, TLS, and custom domains to secure your app. Let's continue.
Securing a web application in Azure App Service with an SSL certificate is fairly straightforward, but there are several options. So we broke them down and we talked about SSL TLS certifications you could have, and then we talked about how you can do the custom domain configuration. To do that, you can simply go to your web portal as I shown you in the previous one, and then assign the custom domain. Either you buy it from the Azure portal itself, or you have bought it from third party, and then you can configure your custom domain with taking properties from there, so like IP address and other settings, and then you can simply secure your app. So like then external users, they can go directly uh, to this domain instead of going to tech of the day by nk.azurewebsites.org. They can directly go to this one, and Azure will redirect your traffic to this domain. Simply this domain is registered on that IP address to this one. So simply it will all your traffic to this one will be listened. Let's continue. Configuring a TLS SSL binding. Once you have got the custom domain configured for your Azure App Service web application, it is easy to do set up a SSL certificate. You just go into the properties of your web app, scroll down on the left, and as I shown you in the portal, and you select the TLS SSL certificate, and there you can just enforce HTTPS only and TLS certificate, and you can upload your certificate for TLS SSL. So which is very important for securing your web app. And and you already have configured the custom domain name. You can also or you might just have an IP based SSL certificate. So what we are going to do here is pick SNI based SSL certificate, and then we will add to the binding, and then your step is done if you have a SNI based certificate. I would suggest you go through this topic on Microsoft Learn for more details. But the key takeaways are: you have to use basic, standard, and premium or isolated plan. Then we talked about public versus private certificate. Then we talked about managed versus unmanaged certificates. And then how can you enforce HTTPS and TLS versions only. So these are the takeaways for this configuration part. Then configuring a secure connection string. Having a database here in your web application architecture is so common that Microsoft has given us some really cool controls here to work with the database connection strings in Azure App Service. So here is the big idea. We have seen building web app service with service web applications, but we might want those to interact with some kind of database. So we can do an Azure SQL database. We could do Azure database on VM, or again leading with managed services is a nice way to go. It makes life a lot easier, but yeah, expensive as well. So let's imagine that we have got an app service web app and an Azure service SQL database. Okay, so you have Azure uh,
So back in the portal and for my website tech of the day, I have configuration part here. If I click here, I go to configuration part, and I can, below down here you have connection strings port, and then in my code I don't have to change a lot, because generally we, how do we reference connection strings is we have separate configuration folder in our application which says connection strings, and then inside that XML we write down our connection strings. So you don't have to change your app, and you can just add connection strings here. And then let's say audit db connection string, and then I will add the value and type um, SQL server, SQL Azure Postgre SQL server, and then I can say okay, because I don't have the connection value here. It just added it, but yeah, I can just edit it and change the value here again, and then it will be using, oh sorry, and then I have my connection string simply, and then I can make use of that connection string in my application. If I go here, use no connection, that was lost. So in here, as I can just add that connection string, and that will stay here. So what I want to say is, you don't have to change your application, and then you can provide connection strings from the portal. This is manual, but you can do the same thing using your deployment methods. So while you were creating the web app itself, you could configure the web app. After you have created, you can then configure the web app using Azure CLI, Azure PowerShell, and you can also do the same with ARM templates or Bicep. That is simply straightforward procedure. Or you can also configure in your CI/CD pipeline, where you just set up you just set up the deployment flow, and then you can, while you are deploying your web app, you can also provide your settings in the connection string. So there are multiple ways to do so. This is one of them, and yeah, let's continue. I hope it is a bit clear.
your web app is up and running, especially for production, it is going to be important for you to keep an eye on it and make sure that there is no performance issue, there is no error, and there is and things like that. So that's why enabling diagnostics logging is so important. Now there is variety of different ways that we could do logging. Number one we have got is application logging, and this could be done with Windows or Linux based app service. This is just a way for us to log messages generated by our application code. So this code would be specific to the web frameworks that we are using, like .NET Core, Node.js, and so on. When you are doing application logging, the messages are assigned to a different category. So for example, you might want to key on critical messages from your application. You might want errors, you might want warnings only. So there is a few different levels that we could do in terms of application logging, and those logs could be stored on a file system of the app service that's running your code, or it could be stored in Azure storage. And next we have got web server logging, and this is specific to the Windows platform in app service, but this is just raw HTTP requests that are coming in. So each message when we are doing web server logging here has all the information about, like, HTTP request that was made, the method, client IP address, a bunch of information. So just a standard web server log. This could be stored on app service like file system or Azure storage again. From there we have the concept of detailed error message. This is concept when you are working in the Windows platform, when you are doing a Windows based app service, and this is a scenario where you might not want to show detailed information to the users about errors that are coming up, but when you are developing, that can be pretty helpful. So if you want to, or you can turn on detailed error message, and you will see those in the browser when you are hitting your web application. By default that is turned off, so we are not exposing sensitive information to users through error messages. We also have support for failed request tracing, and this is again specific to the app service environment where you are running on Windows, and this is just detailed tracing information on failed request. This includes the trace of IS component and that were used to process the request, and the time it takes in each component to finish that process. And finally, we have got deployment logging. This works on Windows and Linux based app service, and these are just logs that you got when you are pushing code to your app service, and that way you can reverse engineer any error that might take place during your deployments. So those are the different options here for enabling diagnostic loggings. Let's jump into the portal and I will show you where you would turn this on all the right. um,
So in the monitoring section, you have a lot of options here. In the monitoring section, you have alerts, metrics, logs, advisor recommendations, health check, diagnostic settings, which we are talking about, app service logs, log stream, process explorer. So we were talking about diagnostic settings, and um, do you want to update them or add them? So to have the diagnostic settings, you see here you can have storage account, event hub, log analytics, workspace, and then partner solutions edit settings. So if when I clicked here, and when I'm here, I can just add diagnostic settings, and then I can give it a name, test diag, let's say, just like that. And then I have many options. What do I want to log and do the settings for? So I want HTTP logs, app service logs, everything, let's say, for the first time I'm saying. And then where do I want to send those diagnostic settings? Do I want to send them to the log analytics workspace? Do I want to archive them to the storage account? Do I want to stream them to Event Hub, and then Event Hub further will can process them? Or do I want to send them to partner solution, where that partner solution is another application which might execute my diagnostic settings and do something about it? So there are many ways to do it, and you can of course do that, and let's say send to partner, and then you can just select the destination here, or you can just do multiple things. You can do it for multiple part. So same way you could do it and send diagnostic settings to uh, a specific location. I will discard it. I hope it's clear. Let's continue.
There are so many third-party systems and tools that you could use to deploy code to Azure. Built in this section, we are going to take a look at the deploying code to app service, deploying code to app service using native capabilities. So let's talk about configuring continuous deployment. So there is a couple of different options here. So when we are going to app service, you could pull your code from GitHub, Bitbucket, or Azure repo, which is part of Azure DevOps. And really what we are doing here is we are associating our web app to basically point to these repositories, a specific branch in these Git repositories. And anytime those branches are updated, it's going to deploy the updated version to your app service application. So this is a continuous deployment option. If you wanted to do continuous delivery, where there was more check along the way, you could use something like Azure DevOps, or you could, some other options like CI/CD systems. So continuous deployment literally means when we change the code, we are going to do an update in the app service. Now, in order to make this work, number one, you have got to have your code in something like GitHub or Bitbucket or Azure repo. But when you have got to, but you also have got to authorize app service to go to retrieve that code. So that's something that you need to do. I'm going to show how to do that in this video, and then once that's done, you can enable continuous deployment there. And again, anytime the developers are updating the code and pushing those updates into the repository, that's going to trigger a deployment. And if you ever want to turn that off, you could just go on into app service and disable continuous deployment. I will show you that as well. So when you are using this native continuous deployment model in app service to get code deployed, it's very simple to do. Let's jump into the Azure portal and I will show you how to set it up, the continuous deployment. Let's go.
All right. So in the deployment center here in my application, I am in deployment part of the app service, and then deployment center. I click this one, and then I have these options: settings, logs, FTPS credentials. So I have already connected my GitHub account to this, and I already have these settings like this. So it is pointing to my repository, and then this is the user I'm signed in, organization, and then GitHub. It also has the logs from the previous deployments and app logs which are there, and then you also have FTPS credentials, which I'm not going to show you. In the settings part, I can this is already connected, so I can just disconnect it, and it is asking me from this workflow file, and I'm going to you see, I'm going to disconnect from this repository. I can copy it again to connect it, and I'm also saving the workflow here, which means it is when I connected this, it created a workflow in the YAML in this GitHub repository. And that workflow is simply a workflow which says how to deploy my application when there is any change. And I am just saying save workflow. I can also say delete workflow file, and it will delete the workflow file. And I say okay. And then it is now disconnecting my GitHub from the source control. So I don't have any setting here now, and I can do the same thing. So to do the CI/CD continuous deployment, I can connect to my GitHub, Bitbucket, local Git, Azure repo. I'm going to connect with the GitHub, and then I'm uh, I'm signed in as this Sharma because it recognized me from previous sign in. And then I can select the organization. I can select, then it is fetching the repositories. I can select and then I can select main branch, and then that's it. And then I can just save it. And then I have the deployment center, deployment here, deployment profile, and it has created the same thing again, a file in the YAML code, which is simply a workflow file. And whenever I will push anything to this GitHub repository, it will create it will simply publish that to this service. So let's continue. I hope it's clear what is a deployment center, how to use.
This is the third module. Once you have created your app and then you have configured your app, then you need scaling your app service, Azure App Service. In this module, in the final module actually of this domain, we are going to take a look at scaling Azure App Service. So after you build your web application, after you configure them, how do you actually run Azure App Service in production? That's the focus of this module. We are going to take a look at the understanding of vertical and horizontal scaling. From there, we will take a look at manual scaling Azure App Service. We will see how we can scale based on the schedule. And then we will finally take a look at implementing auto scaling in Azure App Service. So that's the game plan for this module. Let's go and check out in the next slide. Understanding vertical and horizontal scaling. When it comes to running application in production, one of the things that we have to think about is scalability. So let's review scaling up vertical versus scaling out horizontally. Now let's imagine you have got a virtual machine, a standard A1 V2, 1 core, 2 GB RAM. In that scenario, you have one CPU core and 2 GB memory, and over time the application demands might increase. You might need more resources. So with the virtual machines, we can easily just go to the properties of that VM and make an API call to make the virtual machine bigger, change it to a different size. So we could go to something like a standard A8 MV2, and suddenly we have the 8 CPU core and 64 GB of RAM. And that's just like a small outage to take the machine from the one size to another. So that's the idea with scaling up vertically. Now we know that app service plans are powered by virtual machines. So let's imagine you have got a standard S1 app service plan that is going to give you virtual machine with a single CPU core and 1.75 GB of RAM. And now, just like we discussed, what if over time the resources change and we need to uh, scale up. But the good news is that production grade app service plan tab supports multiple virtual machines, and that's where scaling out horizontally kind of comes into play. Now if we were building all this manually, we would set up in Azure load balancer. We would have some virtual machines connected to that load balancer, and as users hit the load balancer to access web application, the load balancer will spread the connections across the available machines in that pool. And production grade app service plan works the same way. There is an implicit load balancer here which actually see it, and there is an ability to scale out to multiple virtual machines under the hood. So in vertical virtual machine, we were what we were doing, we were upgrading the existing virtual machines to upward, means we were increasing the strength of the existing virtual machines. And for that there was a downtime because we were increasing the existing virtual machine. That means we were taking it down and creating another one, and frankly, and that was not good idea, and might not be good as well, because over the time we might not need that strong virtual machine. We might go back to the same smaller virtual machine, then we will have to remove the existing one and go down. So scaling vertically might not be the best solution. Then the horizontal came in, and then we said, like, if what if we do the same thing, we increase the virtual machine numbers and we add the same instance of virtual machine and add to it. So we have then another virtual machine, and then we have the rule for that as well. And there is an implicit Azure load balancer, as we talked about it. The same thing we were doing in our on-premises applications, and we were having a load balancer, and that was doing the job. So uh, so one of the things that we will see in this module later on is I will show you how to auto scale an app service, and basically we can create rules based on the Azure resource consumption on these machines. So for example, if you have an average CPU consumption, CPU utilization of something like 70%, and that's happening, or maybe 5 minutes straight, we can trigger an auto scale event. So we could do here is our auto scaling rule will add maybe the third virtual machine here, and then the traffic will be diverted to this one as well. So other two are also still working, but if we have more traffic, that the load balancer will start diverting it to third one as well. And again, this is something you could do on your own with virtual machines, but it's also built into app service. So you are going to see this into this module. It's really easy to set it up. Now, in addition to scaling out based on auto scaling rules, we might want to scale based on a schedule. So taking a look at this example, we might scale out at 9 a.m. up to 3 instances from 2 or 1 that we had previously. So we have a predictable workload and requirements. We can scale based on the schedule, and then of course we need to scale in. So we can have scale in rules. So maybe if we are going to doing auto scaling, CPU requirements go down, the CPU demands go down to 20% or less, then we can go scale down. So once at 9 a.m. we increase the CPU number of virtual machines, and then at a specific time we go down, then that means we move one of the virtual machine and we scale in. So if the CPU utilization is less than 20%, we remove that virtual machine, and that is also if it is more than 5 minutes, and then the virtual machine will be removed. So that is like, not when it comes to actually being able to do auto scaling, one thing to remember is that the auto scale feature is only available for standard, premium and isolated pricing tier. Now in addition to auto scale and scaling on schedule, we can also manually scale, and that's what we are going to take a look in this video. Next video, next slide, sorry. it's yeah, it's the same video. Next slide. Okay. So
So
now I
now
will
I will
go
go
back
okay,
to the Azure
so I'm
portal.
back in the portal here, and you see I have selected scaling up, which means scaling with the vertical scaling vertically. And that means when I have some specific traffic, what do I want to do? I have already this service plan. Basically we are changing the service plans actually when we are scaling up and down, or horizontal or vertical, scaling in or out. What we are doing, we are actually changing the app service plan, simple, in simple words. And this is my selected existing service plan, and I can go to this, and then I have this option, apply option. This is manual scaling out, scaling up. I also have the same thing. When I say apply, it will change my existing app service plan to this one. And yeah, and if I want to do the same thing here, scaling out, The auto scale is currently not available for this resource. This resource pricing tier might have been changed and auto scale is not supported. As I said, it is supported in standard. So I have to change it to standard, and to go that I have to go here and change it to the better version of that, and then I can do the scaling out things. But first let's look at the scaling up plans. So if I do B1 here and I just say apply, it is updating my app service plan. And once it is done, oh yeah, and now my app is ready. And now you see I have the option to upgrade scale out manually. So choose how to scale, and then I say one instance is there, two or three instance. So the same type of three instance horizontally I can run. I can see the run history. I can um, oh, again, this is not available in this pricing tier, but anyway, notify diagnostic. So I only have one option, which is manually auto scaling, and that is also with the instance count, and I can just say save. So you see here it says auto built-in feature helps applications perform their best when demand changes. You can choose to scale your resource manually to a specific instance count or via custom auto scale policy that scales based on metrics, threshold, or schedule instance count, which scales during design time windows. Autoscale enables resources to be performant and cost efficient by adding and removing instances based on the demand. So as we talked about it, that's it. I'm going to discard it, and I'm also going to change back to the uh, shared, because I don't want to pay extra. Okay, that's it in this module. Let's continue.
When you have a predictable application, you know exactly what the resource requirements are going to be. Scaling on a schedule is actually really nice. So let's take a look. Really nice. So let's take a look at the properties of this web application here. And as I talked about scaling out, um, how to, and then I shown you how to do custom auto scale, and and I shown you how you can set up some rules in the previous one. And then I said, because I want to do something between because I know my application is using a lot of resources during 9 a.m. to 5 p.m., then I can add some basic rules saying scale out in during this time and scale in during after this time. So basically I will be adding more instances of my application of my app, and then decreasing the instances. When it comes to auto scaling app services, we are basically leaning on some of the capabilities in Azure Monitor. So let's talk from high level really quick about how this works, and then we will jump into the portal to set it up. We are doing auto scaling. We saw this in the video. We have the concept of auto scaling and we know all that, right? We have the basic knowledge about auto scaling, how you do that. And so here, what is happening is you are getting all the matrices from the Azure Monitor, and then based on those matrices, you are creating some rules, right? And these rules have some actions, which are adding, removing virtual machines, emailing, or other webhooks. Or the same thing is used for creating your app, for scaling up your application. So we are doing auto scaling. We saw this in the last video. We have the concept of auto scaling, profiling, and everything. So we saw we could use the schedule, but in this video we are going to take a look using the Azure Monitor metrics. Uh, so now resource matrices for it can be for the existing, or you can perform your own search. So you could also do custom metrics with an app service. We are going to be relying on resource metrics available from Azure Monitor, and this tells us what things about like CPU utilization in our app service, compute instance, memory pressure, things like that. So we are designing auto scaling rule. We are essentially here trying to go into the metrics in Azure Monitor, and we have seen how you could do this based on the schedule. And then of course those rules are firing, and there are different actions that could take place. So for us, when we are dealing with app service in terms of auto scaling and outs or horizontal, we want to be able to add or remove virtual machines based on the rule that we define that are targeting metrics value for the resource we have got in the app service. So again, example, we might want to scale out CPU utilization, which is at 70%. We can also invoke other actions like sending emails, as I said, to the webhook as a net notification to kick off. Or so that's the high level things. And then we need to think uh, about these things. So let's jump into the Azure portal, and I will show you how you can configure or do it. Let's continue.
So here in the portal, you see I am in the monitor section and in the metrics. I have selected one metrics. When you just click here and there, and then you come here, it gives you a scope, my application, and then metrics namespace is just standard metrics namespace is just created. And then here it is giving me some options. You see CPU time. Basically for scaling rules we need CPU related things, or maybe uh, other request related things. So if the average memory working set, average response time, connections, current, so let's say CPU time. Okay, and here it is giving me the average CPU time, and then I want to create new rule. So I just can create an alert rule where the condition is whenever the total CPU time is greater than logic defined in the seconds, and it gives me this cost for every alert. It is expensive. And then I can add another condition here with the average memory working set, data in, data out, CPU time, current assemblies, whatever, handle count, and then aggregate for over last six period 12 hours, um, and then I can set instances, and then I can say okay, include all features, and then static, dynamic, average, threshold value, let's say 4, and then I can just say done. Okay, so I have two rules. This one is not set yet because I need to set value as well. So threshold value is, let's say, the CPU time is greater than, let's say, 20. So I have two conditions here now, and now I need to go and add actions, what actions I want to take. So I have um, already application sites smart detection. I can choose this one and then select it, or I could create action group. So I have already existing I could create another action group as well, which I don't want to. So I'll just go back here. Oh, my changes are not saved here. And then on the details, I'm going to write about the details about this alert and then review, and that's it. So basically you are setting up alerts based on your CPU performance. So that's about it. Same way you could just scale in and out, but okay, that's about it. Let's continue.
Right, that's a wrap. Please write down your comments, questions, and suggestions in the comment box, and good luck with your exam. I hope you learned something, and because I tried to explain everything in my own way, maybe I wasn't clear enough, and maybe you have some feedback for me. So I would really appreciate your feedback. I put a lot of hard work in it, but maybe still it is not enough. I put more than 100 hours in preparing this course because it's really long and uh, it covers a lot of topics. Still, I might not have done a lot of demos maybe, but I would be creating a separate video for that, which will cover labs and some some other exam topics. So thank you for watching and enjoy tech of the day. Enjoy this course and good luck for your exam. Hope it helped you a little bit, at least some degree. Thank you. Have a nice day or evening, whatever is suitable to you. Thank you. Bye. Have a nice day.